This is Dr. Kraus with the last intermediate Python lecture. I'm going to move any remaining topics into advanced Python, but I want to talk about how to use the loadtxt and savetxt functions, which are part of the NumPy module. So NumPy provides these, and they are primarily for reading and writing arrays or matrices to text files. Loadtxt, savetxt. So you could be saving large data sets or whatever, some data that you had read in over serial or whatever, and you just want to write those to a text file or load them in from a text file. But to make full use of them, you need to understand a few common options. So loadtxt, first of all, let's only got 100 Python shells available to me. We'll just start a new one anyways. So because I'm using the NumPy option, loadtxt should be automatically loaded into memory. And so its help says that it's looking for a file name called fname, an incoming a data type to convert the data to. So you've got this data saved as a text file, so everything in there is essentially a string. What kind of data type do we want after we load it? And the default is a float. Lines at the beginning can be automatically ignored if they begin with the comment symbol, and so it defaults to the pound sign, which is the Python comment symbol. I am over 40 and I will not be using the H word. The delimiter defaults to none, but if you scroll down through here, it says by default it's actually any white space. So a space, repeated spaces, or a tab should work by default. Since we're going to pass in CSV data that is literally comma separated, we'll have to pass in a comma as our delimiter. Converters are functions that you would pass in that would map each column to a specific function that would then convert that string to a float. We're going to pass it. So the ones that I want you to be, that I think you'll use the most often, would be delimiter and skip rows. So if you have a certain number of rows at the beginning that don't start with the comment symbol, but you know that they don't contain the floating point data, and so you want to skip them, then you need to pass in a value to skip rows. And I don't know what the rest of those are, so that must be fine. So like I said, delimiter, I said skip row, but it's really skip rows. Yeah, that's bad. Okay. Imagine shooty-roo. Where am I? Yes. Okay. So let's go back into here. But then let's also, I'm going to open up data file 1 CSV. So by the way, while I'm thinking about it, all of this is on my GitHub site. Wow, I don't have a Chrome browser open. That's weird. But I made a special folder underneath intermediate Python. And so if you do a git pull origin master, if you've already got the repository, or a git clone, whatever this thing tells you here, blah, 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 blah. Loadtxt, savetxt contains two different CSV files, which we'll talk about in a second, and then the example for saving the text. So if this is the loadtxt file, so there's apparently 9 lines of header, well, 8 lines of header information, and then 1 line of labels. And so if I just come in here and said data is equal to loadtxt data file 1.csv, it's going to get mad at me. And it's going to say could not convert string to float. And so basically it came in here and said quote SW space. It saw the space and said, okay, that's the first cell. I'm going to convert that to a float, and it couldn't do it. So the first thing we got to do is tell loadtxt to skip 9 rows. Okay, so we say skip rows, remember the S, both S's, skip rows equal 9. thought things were going well. So the first error was could not convert string to float, and the quote SW is kind of a giveaway that something weird was going on. Now it says invalid literal for float, and the string is 0.0, comma 0.0, comma 1.17. Okay, it can't convert that string to a float because it's trying to do this whole row as one thing, and it doesn't have any white space in it, being spaces or tabs, and so that just doesn't work. So then we come in here and say delimiter equals quote, comma, quote. Now data, and let's specifically look at the first, say, 10 rows of it. Starts with 0, 0, 1.75, and then goes 0, 0.1, and those things. And so that seems to agree with the data we have going on here. Now, alternatively, if you were the person to create this text file and you wanted to do yourself a favor, so I had to specify two options to get it to load, right? I had to specify skip rows and I had to specify delimiter. Is that really complicated? No. But maybe if I'm creating the file, it's just as easy to put pound signs, Python comment symbols, in front of the rows that I want to skip, and to use tabs instead of commas. If I do that, I can load data file 1b.csv, and I pass in no options, and I get exactly the same stuff, such that if I took data minus data 1b, I would get a giant matrix of exactly 0. Or I could say data equals data 1b, and I would get a bunch of matrices. Now, that's a little bit of a dangerous thing to do in terms of floating point and round off, so you probably should do the subtraction and see if any of the absolute values of any of the things is above, say, 1 to the negative 12th or something. But yeah, loadtxt, either use skip rows and specify your delimiter, or make sure your delimiter is actually a tab, and all of the rows that you want to skip start with the pound sign. If you do that, loadtxt works well. Now, savetxt essentially does the opposite, but with slightly different options and two required inputs. So you have to specify the file name you want to save it to, but you also need a matrix or an array that you're going to save to a file. Then you have the format, which specifies, how we're going to convert the floating point numbers to strings. So this says use scientific notation always. So even 1 would be 1.0 EE0. And then it says %.18, which means give me 18 digits beyond the decimal point. So, for example, if I said %0.18 E modulo pi, I would get that. If I had instead said, say, 10, I would only, and those are, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's digits beyond the decimal point. If I had said 72, that's 1, 2, 3, 4, 5. I mean, I guess because it's scientific notation, it wouldn't matter. It's always beyond the decimal point. But if you had %f, that's not %e, that's floating point instead of scientific. And then there's also a G that says use scientific if it makes sense, use floating point if it makes sense. I trust you to make smart decisions on my behalf. So I'm confusing the point. So anyways, the default is 18 digits beyond the decimal point using scientific notation, which might not be super easy to read because we got this E plus 00 thing going on out here. Or maybe if you looked at just like, say, 0.1, in G form, that's pretty easy to read. In floating point form, still pretty easy to read. In scientific form, it's a little bit weird. I mean, I think as seniors and mostly, or grad students in mechanical and electrical engineering, you can probably handle, maybe there's some computer engineers in the class, I forget. You can handle scientific notation, but it's probably not super intuitive. But I think this is it's the safest to preserve as many. That's a pretty reasonable number of digits. I mean, it's going to make your text files a little bigger, but I think we live in a world where text file size is pretty minuscule compared to video or audio file size. So making your text files big, probably not a big deal. Okay. Later. Papa's in the middle of recording a video. Please go outside. I will come upstairs in a little bit. So the default for format, %0.18E. Remember that, just in case. The default delimiter is to use a space. Since you're probably passing in arrays of floating point numbers, that's probably fine. If your arrays contain strings, that could be a little weird. The default new line character is a /n. That's probably not going to bother you in any meaningful way, unless you opened your data in like Notepad or something. Notepad doesn't like new lines. At least the last version I'd used didn't. And header is the string we would use to add all the extra stuff we have had at the beginning of our files for the homework, for example, for this intermediate Python. And so it's just a string of stuff to go at the beginning of the file. And it automatically has comment symbols put in front of it. So let's keep that in mind. Okay, so let's look at an example for saving txt. I think I have it open. Yeah. So what I'm going to do is, this is kind of how I would generate the files that are in the intermediate Python text processing homework. So if I had a t vector at 100 hertz, I create a y1 and a y2, and I use the column stack function, which is coming to us from the NumPy module, which means make each of those a column. So if I were to come over here and run, seriously, I can't type, seriously. So data, so one, we could ask what is data.shape, and it is 100 rows by 3 columns, so that kind of tells me that I probably have things going in the right way. And specifically, if you can read scientific notation, you can read down this first column and see that it is going in increments of 1/100th of a second, and so that seems to make sense. So there's my data matrix or 2D array. Then I have some comments that I want to throw up into the header, line 1, line 2, line 3, I just kind of made those up. And then labels are the column labels, which we would want to be comma delimited. So I made a label row by using the comma string to join labels. And so if I came over here and I said show me label row, t1, y1, y2 as a string. And then my header uses the new line character to join my comments. So these are the things that are going in my header. And so if I look at my header, it has line 1 / new line, line 2 / new line, line 3 / new line. Then I add another new line, and then I add the label row. And so if I wanted to print that, it prints out like so. Each line there with the new lines not shown. I mean, they're actually turned into line feeds and not shown as the /n. That's what I mean by that. Okay, then I call the savetxt function. I give it the file name. I give it my data matrix. And again, note that data is just the numbers as floating point values. It doesn't have any labels. It doesn't have any header information. I pass in a delimiter of a comma, and then I pass in header of my header. And we've already seen the value of my header. And I've already run this thing. So if I came over here and said save txt data, you'll note that line 1, line 2, line 3, and like I said, if you looked over here at my header, it has these lines. They don't all start with the comments, but inside the savetxt function, it appends a comment symbol and a space to the beginning of every line. And then here is the data in its %0.18E format. So yeah, I think that is pretty clear. Have a look at the code on GitHub. Play around with trying to load data 1 and data 1b. and then run the savetxt example and see if that makes sense to you.